Okay, year 10, here's our next example. So you may want to pause it here and just read the situation going on here. But it basically says that two people are swimming, and this is the graph of their swims. One swimmer swims backstroke and then returns breaststroke, and the other swims freestyle both directions. So the first question is asking us which swimmer started first and how many seconds before did they start. So if we look at which graph starts first, it's the green graph, which corresponds to swimmer A. So swimmer A started first, and the next part of the question says how many seconds did they start before. So here's 10 seconds, and it looks like our time scales between 0 and 10 have been divided by 5, and so 10 divided by 5 is 2, and I can see that there's 2 squares before the next swimmer starts, and so that would be 2 times 2, which is 4 seconds. And so A starts 4 seconds before B. Okay, the next question says, which swimmer had a rest at the far end? So we're looking for flat parts near the graph, and we can see here that B has a flat part. And so we can write for question B that swimmer B had a rest. Okay, what is the length of the swimming pool? And so the furthest distance they got along was 30 metres, so the length of the swimming pool must be 30 metres. And that's our answer for question C. For question D, how long was swimmer B actually swimming? So the swimming part goes from here to here, and then they're not swimming while they take their rest, and so the next bit goes from here to here. And so if I count up the squares, 1, 2, 3, and then 10, so it's 13, 14, 15, so that's 30 seconds for the first swim, and then they've got 4, 14, 15, so that's 30 seconds for the next. So they actually spend 30 plus 30, which is 60 seconds in total swimming. So 60 seconds. Okay, question E, how does the graph show that the backstroke is faster than the breaststroke? So if we look at swimmer A, the first slope is not as steep as the second, the first slope is steeper than the second slope, and they started with backstroke. And so when you've got a steeper slope, that means it's faster. And so that's simply our answer for why we know it's faster, because it has a steeper slope compared to the second part. So we'll just say that backstroke stroke has a steeper grade, or slope is fine to stay as well. Just say. Okay, question, you can tell that I'm sick. Question F, how long does the graph show that swimmer B swam, we'll start again. How does the graph show that swimmer B swam at the same speed in both directions? Well, that's because that bit there is 30 seconds, and that bit there is 30 seconds, and so because they're travelling the same distance both times, that means that they're travelling the same speed. So since both swims take 30 seconds, they must be travelling at the same speed. There we go. Okay, and finally our last question. What is special about the 2 points marked with asterisks? Where is the other point that could be labelled with an asterisk? Okay, so the interesting thing about where they've marked asterisks on this graph is it shows where these two graphs intersect. So the other place where they could cross is there. So that's our answer for question G. That asterisk shows where the graphs cross, and the other point where this could happen is at 40 seconds. So we could also have an asterisk at 40 seconds. Okay, so you can see hopefully that with graphs, it's all about interpreting. It's really common sense, and you've got to be able to just visualize it in your brain. And so to have a go at a few of these in exercise 12.02, which is on page 346. Thank you.